Warm welcome from my side. My name is Zitzmann, and on behalf of CiA Automation, I'd like to welcome you to today's webinar. So the webinar is about CiA bootloader for CAN-based devices. So as I said, my name is Zitzmann. I hold a degree in electrical engineering from the University Erlangen-Nürnberg. Since 2017, I'm general manager of the CiA Automation GmbH, which is a 100% daughter company of the association. And our main objective is to organize the association and to offer all those services intended by the association to be provided to its members, to provide them in the best and intended way. So always when you want to take part in any working groups, meetings, any CAN automation organized events or marketing opportunities, then you will get in contact with myself and my team, and we try to assist you in the best way. So I have long experience in CAN-based networking since 2004. I'm working with CAN automation and with CAN-based challenges. So as I said, long experience in this area. Yeah, for those of you who do not know who is CAN automation, a brief introduction. CAN automation is the international users and manufacturers group that develops and supports CAN Open and other CAN-based higher layer protocols. The non-profit group was founded in 1992 to provide CAN-based technical product and marketing information. The association fosters the image of CAN technology and also provides a path to future networking technologies. So, first of all, we try to increase the awareness, the visibility of CAN, and second, we try to assist all those people that are working with CAN to overcome CAN-related challenges. So always, when you have or are faced with any CAN-related challenge, then a good idea is to contact CAN Automation to ask, are you aware about this challenge and how can I get out of the mess? And maybe we can help you directly, or maybe we have the possibility to rely on our huge social network of CAN experts. And typically, there is someone who knows about this kind of challenge and can help you so you can accelerate with your development. Brief history about CAN automation. So CAN automation has been founded in 1992 with the objective to increase the visibility of CAN, to assist CAN to propagate into various markets. So CAN had been developed for automotive use cases, but it's not limited to these use cases. It's now used in a broad range of application fields like building automation, like medical application fields, maritime applications. So various fields where CAN is used in high numbers. The unfortunate cases, it's typically embedded, very deeply embedded in the applications. So that is not really visible to the end user. Most of the people are not aware that they are using the daily base CAN-based solutions. Nevertheless, it's then our task to keep this awareness high. To increase the awareness, we use our publications. First of all, the CAN newsletter, which is available since 1992. We go to fairs, trade shows, and explain why it's reasonable to opt for a CAN-based solution. And finally, we pave the ground that people can meet on this neutral ground and can discuss how to use CAN in a specific application field in the best way. So if you have ever had the chance to have a look to the CAN standard, then you will know the CAN itself, data link layer, very good specified, but at the lower end, at the physical layer, you have high degrees of freedom with regard to the cabling, with regard to the connector, the pin assignment. So if you want to have interoperable products, then you have to find some agreements in your specific project how to do these things, which cable to be used, which connectors and pin assignment to be used, and the same on the higher layers, for which purpose do you like to use which kind of data, what shall be the bit encoding and all these things. Yeah, CAN automation allows these discussions, and by the way, it established this network of CAN experts. So warm welcome from my side. Take part of these opportunities offered by CAN automation and take part in these working groups and get connected with other CAN experts. In the second half of this page, you see that a lot of green lines. This means a lot of new developments are ongoing in the CAN. So the CAN is not a finalized technology, and no one is developing here something, but a lot of developments are ongoing, and real tsunami of involvements started in 2012. In 2012, when CAN-FD was presented, CAN with flexible data rate, on occasion of the 13th International CAN Conference organized by CAN Automation. So Bosch explained that there's a certain pressure in the automotive industry to have higher data throughput, and therefore they were forced by the automotive industry to introduce the CAN with flexible data rate. So you may be aware about that you have now data fields of 64 byte size and maximum within one CAN frame if you're using CAN-FD. Then we have thought about how about opening CAN-Open with regard to use CAN-FD to cope with a data field that has such a size. So we published in 2017 already the CAN-Open FD approach 1301. And that days also Bosch came once again and said, the automotive industry demands some more functionality for CAN, and then the development of CAN-XL was started. Although you see this is just one direction, giving CAN a higher data throughput. On the other hand, there were still some developments with regards to CAN-FD. What about increasing and stabilizing the quality of the communication in CAN-FD based networks? So the upcoming of the SIG transceiver. What about of using CAN-FD in very simple applications, so like light control in cars, but also battery management and something like that. So for this purpose, the CAN-FD Lite approach was developed. And then also there was the finalization of the CAN-XL developments, and also this CAN-XL as well as CAN-FD Lite, CAN-SIG transceivers, everything was then introduced in the new editions of the ISO standards, which are available since the last year. So you see, a lot of development is ongoing in the CAN, and there are still developments now with regard to security and other things. And on this last page, you saw also there were some thoughts about harmonizing a bootloader functionality. How can we come to a kind of generic CAN-Open bootloader solution? I will say then somewhat later on when we come into the core topic of the day. But you see that CAN is still playing an important role in the market. You see, we have still a lot of CAN automation members. Currently, we have about 730 member companies. So a lot of companies think it's worthwhile being a member of this social network offered by CAN Automation, where I get latest news on the developments in CAN. Where do these members come from? Most of them are coming from German-speaking countries. Then the second major part is located in the US, and then it's diversified over the globe. So you see, we do not only propagate CAN over the markets, but also the globe. And for you, if you are taking part from a company that has some subsidiaries all over the world, then I just want to inform you that we are also very happy if you can assist your colleagues somewhere on the globe. And if there's a need, we will go there and teach them and discuss with them how to use CAN the best way. You see also how our membership is derived from. So most of our members are device suppliers, some are system designers, and then it is diversified over the other categories. Just that you know, CAN Automation mainly is focused on the development and maintenance of CiA specifications. Nevertheless, we want to inform you what's going on in the CAN business, which new specifications do exist, which new solutions are available on the market. So therefore, we have our publications, and the other way around, we try to assist you with technical support. So summarizing, we offer you technical marketing-oriented services in a system or device manufacturers-oriented way. I think this you know already. Therefore, I just want to highlight one or two groups that may be also relevant for today. So today we will also have a look to CanOpen. So I think you're interested in CanOpen, and therefore you might be interested in our new marketing initiative that has not only in mind CanOpen FD or CanOpen Classic, but has both flavors of CanOpen in mind, and is evaluating how can we increase the visibility of CanOpen and raise the awareness for CanOpen. So this group is meeting next week. And furthermore, we have another active marketing group with regard to CanXL. What are these marketing groups doing? They are evaluating how can we convince people using CanOpen in this case, how can we double check why it is reasonable to use a CAN-based, CanOpen-based solution for this and that purpose. Therefore, we maintain a website, organize technology days, and so on. And coming closer to the topic of today, we have also our technical working groups, and among others, dealing with the lower layers, with CanFD, CanXL, dealing with the profiles, and other things. We have one group that is talking about a harmonized bootloader application. So there were some companies suffering that updating devices in the field is so different for any type of device, and therefore they said, maybe it's wise to found a group in CAN automation, and let's talk about harmonizing bootloader options. And this is then under the technical committee, a task force, the task force bootloader, and this will be subject of the day. I think you know that we are active in the standardization, that we occupy the CAN standardization, that we discuss latest news then from the standardization, from networking in our international CAN conferences. The proceedings of these CAN conferences are available on CAN Automation's website, which is anyway a treasure trove for you if you are searching for any kind of information. And finally, I'd like to highlight that we will have a Members Day upcoming very soon in February 25th, 26th. Embedded into these Members Days, there is the CiA General Assembly, and the CiA Assembly is enriched by some technical talks. You see here the lineup, and the first day on the second day, and it's finalized by an open workshop, which is also open to CiA non-members, where Mr. C from Infineon and Mr. Tyndall are giving a workshop about identification of CAN. It is having in focus some cybersecurity aspects and how to use cybersecurity mechanisms that have been invented for Ethernet on a CanXL application, or maybe also even on CanFD, I don't know. It will be the open workshops topic. Yeah, so maybe we meet there. If you want to register, you find here where and how, otherwise also on CAN Automation's website. Yeah, let's come to the core topic, CiA bootloader for CAN-based devices. Yeah, what is a CanOpen bootloader? So I summarized here some definitions or descriptions. So first of all, a bootloader enables field updates of the application software, and in particular, a CAN bootloader, a bootloader for controller area network-based devices, enables the firmware updates via the CAN interface. So typically, the bootloader application is located in the start location of the device flash memory and uses a switch as bootloader trigger to force entering the bootloader mode, let's say, at reset of the device. So far, I think we have a common agreement. Subsequently, we have proprietary protocols and procedures to be executed to prepare device to be updated, to transfer the new application program firmware typically and to activate it. And we use this in a variety of so-called fields, as we said in the first point, and field updates. What means field? This may be in the laboratory, this may be end-of-line production, this may be an operating system somewhere in a factory hall, or this may be also updates over the air for the superstructures of a truck or something like that. So far, everything is solved. If you type in Google, you need a bootloader for certain semiconductors, then you see all of the semiconductor manufacturers, they have their bootloader mechanisms also via CAN, so everything is solved, job done. But there's one small thing. In bullet point 4, we see here the nice word proprietary. So if I want to update the firmware of a device, it depends always, okay, which manufacturer, from which manufacturer is this hardware, and then I have to double check, okay, what are the proprietary protocols to update the device in the field. And now to overcome this, some agreements are necessary that you say, okay, isn't there a possibility to provide a harmonized mechanism, in particular, if I want to update the devices in a running system that is installed somewhere and I have to come over there, then it would be very great if I don't depend always on a certain manufacturer's proprietary protocols, but if I have a harmonized solution. Harmonizing a little bit the device architecture, this is already done by CANopen. So CANopen introduces a device architecture that clarifies where in my device do I find the data. So this is in CANopen, the CANopen object dictionary. There can I maintain my data, a proprietary or standardized way. And I have some communication objects. These communication objects may indicate from which origin is the device, who is the device manufacturer, what's the serial number, and so on, which kind of software is supported. And furthermore, it provides me some parameters that allow to adjust the intended communication services. So CANopen does not only introduce a device model and a database, but also a lot of services to control the device, to configure the device, and to do some diagnostics. And two of the services are intended mainly for data transport, the SDO and the PDO. I think you know this. In particular, the SDO is intended for a standardized mean for data transport. So CANopen helps us already a lot on the way to achieve a harmonized bootloader. Then I'd like to remind you on the NMT finite state machine. So not in any device state I like to do a firmware update, but only dedicated ones. Therefore, it's maybe good to remind us on the device states a CANopen device may have. When I switch on a device, it resets its application, the communication parameter, applies the node ID, CANopen device also network ID, it applies the bit rate, and when everything is initialized, then my device can transit to the so-called communicating state, so pre-operational, operational, or stop state. So typically, the pre-operational state is a state that is intended for configuration. So also here, services run for data transport and configuration of the device. And then I know where is my target, where can I hand over the data. I see here the object dictionary, and also in a bootloader mode, which is just a minimal implementation typically of a CANopen device. There I want to know some information, maybe which kind of application program or firmware is currently running, or is there at least one running. What is the version number of this application firmware, and maybe some other kind of information. And I know this because I have the object dictionary. Yeah. For CANopen, we have now, as you've seen, we have the data, we have the device architecture, we know where's the data, we know which kind of services, we know how to treat the device to put it in the right device state for the data transfer. And furthermore, we know CanOpen is not just one monolithic profile, but CanOpen is an entire profile family with a broad range of documents. And there exists the document 302, and the document 302 provides us also with a mechanism for the bootloader, for program download, for firmware update. So a lot of guidelines are provided there for the bootloader, and we will double check this, how they work. Furthermore, we have already seen CanOpen Classic, as we call this first one, was now enhanced. CanOpen was enhanced in a way that it is capable to run on a CanFD data link layer. The outcome is called CanOpenFD, and the specification range for CanOpenFD is in the number area 1300, and we have there the document 1301, which is CanOpenFD. And we are currently working on a 1302, but there's quite a big effort, and we are still working on that. Nevertheless, there exists in between a number range 700, and these are somehow documents that apply for both worlds, for the world of classic CanOpen and the world of CanOpenFD. And there appears something that is the document 710. And the 710 document says, okay, I provide a harmonized mechanism for bootloader in CanOpen world, and I consider both CanOpen Classic as well as CanOpenFD. So both profiles provide the toolboxes which are available, and 710 says then, okay, use the right tools to provide this result, which is demanded in 710. So, according to CiA 302, part 3, let's see what is a CanOpen bootloader. A CanOpen bootloader is a software in a CanOpen device that is able to receive the data of a program download and start the program. The bootloader is called active. There is no program software running that provides CanOpen functionality. It is not defined in the specification which objects are a mandatory part of a bootloader and how a bootloader can be detected by a CanOpen manager or tool. This way specified a profile. Whenever a CanOpen device comprises such a bootloader, the bootloader is active. Object 1000 shall return the value of that bootloader device profile. If one or more programs are started that provide the functionality of a CanOpen device, the value of object 1000 shall return the corresponding. So we see, okay, we have a proper definition. Now let's see what else is defined in the document 302. And there we see a flowchart. How shall we do this, bootloader procedure? So first of all, we are checking software. Is there software available? Is it of the right origin? Is it the right version number? And if everything is correct, then we can say, okay, go ahead. But if we say, okay, there's an update needed, then we say, okay, let's start with the update. Is there a reset allowed after the updating or not? And then if everything is clarified, we can do the update according to this flowchart. And if everything is successfully handled, then we can start the program, and we can finally double check whether now the new application software is running correctly. So sounds according to a proper approach. Therefore, to make this proper approach running, we have also several objects for our object dictionary. So we know where to store the program, so in the device to be updated. So we can double check, do we have their program at all? If there's a program, is it of the right version? And we can control the program, we can start, we can stop, we can erase the program. So everything is available what we need. So furthermore, we have the possibility to see the flash status. So is the device, what is the device currently doing? And is the device ready to accept the data? And finally, we have the possibility to give the manager device some information. What is an expected program software identification? and what is the data, the application data to be downloaded to the devices, so that these devices can then apply this application data as new application program and execute it. Now, everything seems to be properly fine. Now let's see how we live this in our profiles. We see here 417 for lift control, which claims it is based on CiA 302. And we see here there was the idea, okay, to keep everything simple, a device in bootloader mode shall claim the node ID 126. So I see immediately, is there a device in bootloader mode? And I can treat this device, and I don't need any dynamic node ID assignment methods and all these things. I have a couple of mandatory objects to run the bootloader, to execute the bootloader. The device shall transmit the heartbeat, so I can see the device is always available. We distinguish clearly between a bootloader mode and application mode, and there's also defined when to transit into the bootloader mode and when to return. Furthermore, there was some consideration with regard to cybersecurity issues. So how can the device that gets the data, the application data, how can the device trust the data? How can the device verify that this is really a correct one? Therefore, there can be some identification hash values integrated in the firmware so that the device is able to double check this is really legal software. Now, also the profile for subsea instruments claims we are using a bootloader according to 302-3. But in our case, we don't rely on a fixed node ID. We need in the bootloader mode the so-called layer setting services for dynamic node ID assignment and even for bitrate changing. Then we want to make sure that no one is in an unintended way erasing the program. So therefore, we want to have another program lock. We don't want to have a heartbeat transmission. We want minimized communication effort. And also here, there's a distinguishing between the bootloader mode and the application mode. And there are also some guidelines with regard to mode switching, and immediately after power on, any 443 device is starting in the bootloader mode. So 302 as well, but a little bit different than the approach that is used in elevator control. And for energy management, this is once again a little different with regard to the node ID. We are very close to the 417, the elevator approach. And here we have also another switch for the disabling of the firmware. And this was introduced because we have here not necessarily the case that the host controller is also the NMT master. So therefore, we cannot rely on NMT services to trigger the switch between the application mode and the bootloader mode, but this may be triggered by writing via SDO to the object dictionary to this object 6005A. And furthermore, we get here the hint, there exists some application statuses on our devices that may prevent the switching to the bootloader mode. So my application may be in a certain action that has to be finalized. Then I get the indication from the application, okay, now we can leave the application mode. Now we can go to the bootloader. So you see, in the various application fields, that we have different requirements. The bootloader works always slightly different, although it claims it's based on CiA 302. And this triggered then also our technical director in these days to say, okay, if I'm manufacturing tools and they should update all the CanOpen devices or should be capable to provide a bootloader mechanism to all the CanOpen devices, then we should harmonize here a little bit, clarify, and point out what is the intended way of using the 302 bootloader. And prior to come to that, just some remarks with regard to Object 1000. Also, this is affected by a bootloader because depending on the firmware that you are downloading on the device, executing on the device, the content of the Object 1000 may change. So the Object 1000, at least significant 16-bit, shows which profile is supported. So this may be 4 or 6 for an encoder, but if this encoder is just a positioning unit for a lift, this is suddenly 417. So it depends which kind of application program you execute on the device. The content of Object 1000 may change. And there were also the demands in some application fields that you can see direct in the Object 1000. Is the device in the application mode, executing an application, or is the device in a bootloader mode? And therefore, the CAN OpenFD specification took the upper 4 bits of the device profile number and said, okay, they have been never used in classic CAN Open. Now, why not using them to indicate something that is called a specific function, and it entitles us to indicate the device is currently in a bootloader mode. So we see here the field definition for that specific functions. And in this one, there we can see that the device is in the bootloader mode. So it's here unfortunately written, but this is the extension. Yeah, as I've summarized already, the status quo was that we have several flavors, let's say, of the bootloader mode, how to enter the bootloader mode, by password writing, by certain application states, by certain NMT states that have to be fulfilled. The node ID handling was quite unsure. Which kind of CAN Open services have to be supported? What about the firmware to entitle the device to be updated? That this is a legal firmware. How to treat the Object 1000? All this was somehow unsure. And therefore, there was the foundation of this task force, generic bootloader, which has now almost done its job. So we are on a quite final state, but we think about this, it's about 1 year. But there are always coming new requirements, new comments. So nevertheless, we hope that we can finalize and publish this document soon. So the use cases that we have in mind are all those that I've already mentioned. Simple, very simple laboratory use case that you say, okay, just give the device a node ID, adjust a bitrate, and then in a very controlled area in a one-to-one session, you can switch the device into the bootloader, hand over the new firmware, and update the device. A little bit more complicated is the end-of-line production. There you have not necessarily a CAN Open expert there, but this may be just a production assistant who is connecting several devices, and then maybe a PLC is then accessing these devices and updating to all of the devices. The firmware, always the same one, and you can think about that you may have here 1 to n sessions to increase the speed of this updating process. But nevertheless, it's a rather simple process. Maybe you have to use here some dynamic node ID assignment depending on the setup of this end-of-line production. A little more complicated is then the update in the field, because you don't necessarily know which node IDs are already used. You don't necessarily know, do the devices support a layer setting service or something like that. So we have seen in 417, it is maybe simpler to work one device after the other, to update one device after the other, and then you can say, okay, if I switch a device into bootloader mode, it claims a specific node ID, which is reserved for devices in bootloader mode, and treat one after the other. I can simplify everything, the implementations, and with a minimum of effort, I can update one device after the other. Okay, it may be time consuming, but from the implementation point of view, it may keep the thing simple. And the most complicated case is maybe that one that you come over the air via an IoT gateway and access then your application. I want to do some updates here. So here you have not necessarily an expert out in the field who can fix something. You have not necessarily network management services from a manager point of view. So this may be a little bit complicated here. But all those use cases we had in mind. And now let's see which kind of cases we have discussed now. So all these issues we discussed, we considered by the group. We try to define the definition of the transition between to the bootloader mode and the application mode. How can we switch from one mode to the other and back? Are there any dependencies to the network management state machine, to the application state? What about passport writing, unlocking, locking the device? What about the availability of the right firmware? All those things we try to consider. We provided some recommendations with regard to the node ID handling, when to use fixed node IDs, LSS, dynamic node ID assignment. We try to clarify which objects, which parameters in the object dictionary should be supported, which are not recommended to keep the bootloader rather small, how to treat the object 1000, which categories should be supported. For example, the heartbeat service should be supported, the USD or block transfer should be supported to make the thing simple. What about handling of multiple programs? What about handling of configuration files? Then the consideration of the capability to update only shares of the firmware was discussed, and also provided some information in the document. What about the question that the bootloader itself should be updatable? Is this also just an application program? What about a rollback function? Also, this has been integrated, that you say there is always a certain danger that firmware update fails, and then the device shouldn't be in an undefined state, but should be in a very defined one. What about authentication mechanisms for bootloader activation, for program download, configuration download? And finally, we discussed also how generic can this work item be. And we haven't at this level yet, but nevertheless, there exists even an idea that you can say, okay, maybe on a frame base, you could also implement this without can open, but on the data link layer level, let's say, that you say, okay, just give the can frame content and use this approach. And finally, there are also some considerations from the client view. So how should a client address any can open device to update it? So all these things are addressed in the document. The document that we are currently having in the release process at CiA Automations, the document 710. So the documents CiA 302 and 1302, which is an upcoming document, are providing the toolboxes. And CiA 710 harmonizes everything, says how to use the tools to allow this harmonized bootloader. First of all, we tried to find the dependencies between an application mode and a bootloader mode, how to start a can open device. First of all, we have a new state, that is a bootloader initializing. In this bootloader initializing, I may have something that is called an auto start. So here the device may check, do I have a valid application program? Is it a correct application program? And is it labeled as an application program that I should start, first of all, when I'm powering on, or if I have several application programs, which is that one that I should start, which are maybe redundant one or no prior ones. If I don't have any application program or any correct one, then I can go on with starting in the bootloader mode, and then I have something that is what I would say the normal can open FSA, where I do my initializing and start the can open device final state machine. Or if I have an application program, I go directly into the application mode and start my can open device. In parallel, I have this definition bootloader mode active or application mode active. And if I want now to hand over a new application program to my device, I have to authorize myself with regard to the device and say, hey, I'm a legal user. I write a certain password, and then my device knows, okay, I'm allowed, and we can now leave the application mode to bootloader mode. But we have to double check, are there any dependencies to the local application? Is the device currently running the drive currently moving and has to be placed at a certain position. Then we can go to the bootloader mode. And then I go back here and can then hand over the new application program, start the application program, and activate the application program. So we have designed the state machine. It should be very clear. All states are defined, all transitions or trigger events are defined in the specification 710. We have also thought about the node ID handling then in context with this state machines. We couldn't find an agreement. It should be with node IDs anyway, in this way and that way, because we figured out there exist use cases where you can have different or must have different node IDs in application mode and bootloader mode. The most simple one is, of course, if they can be identical, and there exist other use cases where it's an obligation that the devices forget their node ID as soon as they enter the bootloader. And in particular, if you have the use case, what I figured out in the laboratory, it can be very good if you have the layer setting services, not only for node and network IT addressing, but also for switching dynamically the communication speed. This allows you, in case of doubt, a rapid transfer of the application data of the software. It's always good to know if something is going wrong and to know this in a very fast way. So therefore, we have here the flash status indication. It is already an object that had been introduced in CiA 302, but we have extended it and we have now more fine-tuned error information. And this means manager device, a tool, can directly see what's going on in the device. It's not necessary to read this data content, but we have there also a mapping to the emergency service. So the device by itself informs the tool, hey, what's going on here? I have some problems, the flash not cleared or whatever. So this, of course, demands that the emergency service is supported also in bootloader mode. I know not everyone likes this because in many applications, bootloader mode protocol stack shall be as small as possible. But if you have this size possibility, then this could be a good option. It could be a very helpful option. The rollback function, as I already explained, there's always the possibility that a new downloaded program is defective. So one program can be marked as a default program that cannot be deleted. And if there's a bootloader mode, a tool, or even the device itself is unable to run a recover operation, so the device got not lost, but goes then to this default program. With regard to the question, which kind of services shall be supported, it was not possible to say this is a must and this shall be not, but we provided some recommendations where we say, okay, emergency is often very helpful, but it's an optional thing, and if the demand to have a very small stack is more important, then leave it away. PDO time sync is not recommended. The SDO for classic and open device is of course needed in a server way so that I can hand over the data. Further SDO functionality is not needed. With regard to the time of SDO transfer, the block transfer of course is nice because it allows a very accelerated transfer. For the USDO, of course, one server is mandatory, and with the bulk transfer, and even if you have it in multicast or broadcast, this is a very efficient transfer, in particular with regard to end-of-line production. Heartbeat. So the producer heartbeat functionality according to CiA 110 is mandatory. Now one may say, well, but I want to keep the devices calm, as we have seen in 443 approach. Okay, this means then you have to switch off the heartbeat functionality, so you support it, but switch it off, then you can have your desired behavior, but in general it should be available. Boot up is mandatory, so we cannot go download this anyway, and NMT need to be consumed. So this means you have the server functionality, not necessarily the manager functionality. This needs to be switched off. And finally, the layer setting services can be sometimes very helpful. In some applications, they are needed, they are mandatory, but from a general point of view, they are optional. So we discussed also the lineup, what kind of object dictionary entries are needed with regard to the bootloader. So we see at the start what is introduced by the CanOpen sorry, 301. And we see then some additional objects coming from CiA 302, like the object 1F50, where to provide the program data, where to control the program, and where to read the program software identification, the flash status. Here with the yellow lines, we did some modifications, some amendments to allow some increased functionality. And all the green ones, we have now new functionality introduced by the document 710, like the auto start of application programs, the handling of the security access, a mode switch counter. Is mode switching immediately after the triggering event possible, or do I have to wait a given time for doing some final tasks that need to be fulfilled prior to the mode switching? Do I have to wait for external triggers for the mode switching? Or this is not possible via the mode switch timeout counter. If I need a software switch via STO, I can have the bootloader mode switch here, 1F5C. Then there was a special demand from the Lyft guys to have a clear string about the software version, and others wanted to know what is the identity of my bootloader, 1F5E, and finally, I need also to read some timeout flash operations so that I know from a manager point of view how to handle the device and what timeouts do I have to expect during this bootloader procedure. So you see here that what I have already explained, the auto start, which application program started after power on, security access, I hand over here the domain. As I've said, the mode switch timeout. Do I need some time to finalize certain tasks prior to the mode switching? Do I have to wait for external triggers? SDO possibility to trigger the mode switch, a version string, so everything what I've explained already to the last slide. So finally, it is assumed that there's a CanOpen device running an outdated application program and that requires an update, and therefore the 710 provides a handling procedure. So these given steps here are required to update the application program. The description of the sequence is given from the point of view of a generic bootloader client. So you will find then several sequence diagrams in the annex of the document 710 that clarify directly, message by message, what do I have to do. So first of all, you need to get access to the protected data elements. So you have to execute the security access for getting access to program data, program control, and so on. And you have to trigger the switch from application mode to bootloader mode. You have to erase the memory and the related application program. You have to download then the new application program when the memory is prepared. Then you have to verify that the right application program is correctly downloaded. You can think about the autostat if you like to do so, support that, and then you start the program and leave the bootloader mode. So these steps are defined and also given sequence diagrams how they work. This is just one step of these steps I've introduced. This is a step of downloading then the application program, where you double check once again whether your device with the memory is prepared. And if the flash and everything is prepared and you know the operation timeout, then you can hand over the data right to the flash, and you can double check is then the data successful in the flash, and so you are done with this step. And in this way, all these tasks, as were introduced in the last slide, are explained in this CiA 710. Yeah, so we hope with the document 710, the generic bootloader, we can assist you to provide a harmonized handling for firmware update. It uses the means that have already been specified in CiA 302-3 and takes the learnings from further application fields like elevator control, subsea control, and others into account. So Thus, the base is prepared to allow generic CAN and open tools using one typical handling procedure for simple firmware updates. The tool manager client view is covered by the sequence diagrams, as I've shown in the last slide. So CiA 710 is still a work draft. It's, let's say, a final work draft. And it's currently not only by the task force, but also by the technical committee in the voting, and will be discussed next week. So unfortunately, I've received a lot of comments. So I think we will furthermore update the document because there are some little further feature requests. So nevertheless, we are still optimistic that in this first half of 2025, we can release the document. And any CAN automation member has access to this final work draft. So I invite you to have a look to this document and to make use of it, hopefully. We are also available on social media. So we provide there a lot of information. We have also a look to our specifications, to our publications that provide always the latest trends, such as the community news, which appears in a 3-weekly base. On our website, you find here in particular in the section activities, always the latest activities with regard to webinars, meetings, seminars, technology days, and so on. So I depicted here on this slide when are the next technology days where we go together with our members into depth in certain topics. So the next one will be the CAN OpenFD approach, but we have also others like CAN-based network, mobile machines, agriculture machines, further webinars where we're talking about CAN-FD, functional safety, and others. And we have also some workshops. These workshops are intended to start discussions in certain application fields where we want to see, can we assist the users there by writing a new specification, writing new guidelines or other things, so to increase the interoperability between devices of actors acting in a given application field, like greenhouse automation, service robots, or introducing cybersecurity in CAN-based systems. Where you can meet us on several fairs this year. So the next one will be the Embedded World in Nuremberg. We will exhibit there CAN FD Lite, sorry. We will have 3 demonstrators presented by Bosch, Vector, and ST Microelectronics. We have seminars, but this you can browse through by your own. Yeah, and if you want to contact us, you see here the contact addresses.